Hi guys, we are going to be starting lesson 1-1. I hope you watch the lesson overview before you start this video. It gives you an idea in general why we're doing what we're doing, okay? Which is to solve real life equations eventually, taken from an application problem, okay? But before we do that, we're going to start just with solving equations, a couple different types. I think what you'll notice is college algebra's pace is very quick. Okay, so we're going to start with familiar territory and then gradually we'll be heading into some unfamiliar territory. But right now, I just want to remind you the goal in solving equations is, of course, to isolate the variable. Okay, we want the answer to be x equals 10, x equals 3, whatever. I just want x by itself with what value I can stick in for x and make the equation true. So, of course, we've learned how to do that in Algebra 1. Okay, we use inverse operations, correct? I find my x, and then I start undoing things in the reverse order. So the first thing I want to do is get rid of this minus 12. Okay, I want x by itself over here. So, of course, whatever I do to one side, I do to the other. So I'm going to add 12 to both sides. Okay. When I do that, negative 12 plus 12 is 0. It's the reason I added 12. And over here, I have 22. Okay, I still, of course, have the x divided by 4 as well. So I have something divided by 4 equals 22. Sometimes people see it right there. If you don't, though, you still undo what is being done to x. X is being divided by 4, so I'm going to multiply both sides by 4. Because when I multiply both sides by 4, I get 4x over 4, and 4 over 4, as we know, is 1. So I have x equals 88. Of course, to double check it, I would take my answer that I got, 88, and put it back in for x. 88 divided by 4 is 22. 22 minus 12, yep, that's 10. Okay, so here I have subtraction again. All right, and sometimes people get confused when there's a negative on the other side. I'm still going to add 3 to both sides, okay? I get a negative 13 plus 3, which is a negative 10. So I have 5 times something is negative 10. This time, what's being done to x is a 5 is being multiplied by it. To get rid of multiplication, I'll divide both sides by 5. Again, I have the 5 over 5 is 1. So I have x equals negative 2. And again, I would double check that by sticking it back in the equation. 5 times negative 2 is negative 10. Negative 10 minus 3, yep, that's negative 13. Okay, and again, people get confused when there's fractions sometimes. This is negative 2/3 multiplied by x. So to undo multiplication, I'm going to divide by negative 2/3. However, dividing by negative 2/3 is the same as multiplying by negative 3/2. Okay, I don't like to divide by a fraction. So I'm going to multiply by the reciprocal. I'm going to multiply by negative 3/2. That gives me 6 over 6. Well, that's 1. So that gives me 1x. I multiply my numerators. I get 27 over 2. Okay, so you can write that as 27 over 2. That's fine with me. You can write it as 13.5. That's fine with me. You can write it as 13.5. That's fine with me. Guess what, guys? We're in college now, sort of. So we're in college algebra, and those are all the same number. Okay, I get so frustrated when people are like, oh, I want it in a different form. I don't care. 13.5 is the same as 13.5, which is the same as 27 halves. Give me one of those answers, okay? And I'll be happy. All right. I'm not going to tell you which way to write it. Everybody has their own favorite. Okay. We good? Remember that? All right. Let's see what's next. Sorry, I'm getting used to this Wacom tablet. Okay. Ah! I messed it up. Okay, let's see if I can, I'm gonna go back. Okay. All right, so sometimes the equations are a little bit longer. We have a bunch of x's, right? That's not what we want. We do not want a bunch of x's. So I first use the distributive property if I have to, okay? I have this -1 and then I need to distribute through the parentheses here, multiply. Okay, let's get rid of the parentheses. So I have 4x minus 3x plus 5 equals 2x plus 11. Right, I'm assuming you understand that the negative times the negative is a positive 5, and this is -1 times 3x is minus 3x, or I don't really like the plus and negative. I don't use that a lot. I'm not going to take off if you do, but I write minus instead of plus and negative. 4x minus 3x. I'm going to combine like terms. 4x's minus 3x's, that's 1x. Okay, now I have an x on the left, an x on the right. Stand up, sit down, fight, fight, fight. When we have a variable on each side, we want to get it on one side. So I decide what I want to do. I'm either going to subtract x from both sides or subtract 2x from both sides. I like to keep my x's positive, but some people like to keep x on the left. It doesn't matter. Whichever way you want. I'm going to subtract x. So 2x's minus 1x is 1x. We have 5 equals x plus 11. And then we're going to use our inverse operations to finish it off. I'm going to subtract 11 from both sides to give me that x is -6. Okay, and then you can always check it. Let's see here. It's a little bit harder to check, and sometimes, quite honestly, I don't. But if I'm handing in a test or quiz, I do. 4 times -6 is -24. Minus 3 times -6 is -18. -18 minus 5 is -23. So minus -23 equals 2 times -6 is -12 plus 11. So on the left, see, minus a negative, looks like I have -1, and on the right I have -1. Yep, left side equals the right side, so -6 is correct. Okay, hope we're good. All right, let's try these. You can try them on, you can always pause me and try them on your own. It's a good way to learn. If you don't want to pause me, then we are going to do these 3 separate equations, and I want to show you what happens, okay? So I have, I'm going to distribute 3x minus 18 equals 2x minus 18. I'm going to subtract 2x from both sides. I have, whoops, sorry, x minus 18 equals -18. Okay, I'm going to add 18 to both sides. And sometimes what happens when the answer is 0, okay, this is x equals 0 is the answer. Sorry, that looks like an x1 there. I don't know what, something funky is happening. X equals 0 is the correct answer. Okay, 0 is a number, and sometimes it's the answer. Here we have 3x minus 18 again equals 3x plus 18. I try to subtract 3x from both sides, and all my x's disappear. 18, wait, -18 equals 18. Does -18 equal 18? I don't think so. So sometimes when we're solving an equation, there is no real number that works. No solution, guys. There isn't an x such that 3x plus 18 is going to equal, 3x minus 18 is going to equal 3x plus 18. Not going to happen. Okay, and our last type, 3x minus 18 equals 3x minus 18. Sometimes you can see it right there, especially when I'm saying it out loud. Isn't that always going to be true? right? It's the same thing on left and right, but sometimes people don't notice it because you're kind of just in the mode of solving. Subtract, you get negative 18 equals negative 18. Yeah, negative 18 does equal negative 18 all the time. So the answer is all real numbers. You stick any number you want in there, and the left side will equal the right side. Okay? Sorry. So the different things that we have then. Sorry, I can't get away from here. Let me just. Okay, so here are the different things that can happen. I either get an answer, like here, x equals 0, x equals 2, x equals something, or I don't get any answers at all. There's just no solution, or every answer works. Okay, so you either get an answer or two. Okay, in this case, since it's a linear equation, we're just going to get one answer, no solution, or all real numbers. Okay? When it's all real numbers, oftentimes it's called an identity. Okay, the left side actually equals the right side. So you might see that in the book sometimes. All real numbers is, they'll say it's an identity. Okay? All right, now we're going to move forward to solving equations like this. What's different, guys? What do we have here? The dreaded denominator. I know we don't like that sometimes, but hey, rational equations are something we're going to have to get over. We're going to see them all year long, okay? Sometimes our x is in the denominator. Now, what happens in these cases is there are some answers that just can't be. What can't x possibly be? Looking at it, what can x not ever be? A lot of people will say 0, but x could be 0 in this case. 0 minus 1 is negative 1. What x can't be is whatever's going to make the denominator 0. So in this case, when x is 1, I'd be trying to put 1 in here, and I'd be like, 1 over 0? Nope. So whatever happens, I have to restrict what might happen, okay? Whatever happens here, x cannot equal 1, okay? So I'll go ahead and solve the problem, but if I get x equals 1, then I know not working, okay? So oftentimes what we do is we try to get a common denominator, okay? Our denominators are 2. Another denominator is x minus 1. So I would like each denominator to be 2 times x minus 1. Okay, I would like both denominators to be that. So I look here, this has a 2 already, but it doesn't have an x minus 1. So I'm going to have to multiply the top by x minus 1. 1 times x minus 1. If you notice, this fraction is still 1/2. The x minus 1's cancel. This has an x minus 1, but it doesn't have the 2. So I'm going to have to multiply 1 times 2. Okay, so you get your common denominator, and then you go from there. Now once I have the same denominator, I just add my numerators. X minus 1 plus 2 all over 2 times x minus 1 equals 1. Combine my like terms, negative 1 plus 1 is 1. So it looks like I have x plus 1 over 2 times x minus 1 equals 1. Now, as soon as I have a fraction equal to just a number, I can multiply the denominator by the other side. Hey, these videos can only be 15 minutes, so I'm going to keep everything right here. This is lesson 1, part 1. Go to lesson 1, part 2 for the rest, okay? See you in a couple.